Hello, I'm Anna Mackay and this video is on second derivatives. For my students, make sure you're writing down everything you see on every screen. So what are we dealing with? The second derivative is the derivative of the first derivative. In future topics, we'll go on to look at what this means graphically and in applied types of questions, but for now we're just practicing the skill of finding the second derivative. In terms of the notation, here's the y and the f notation. Here's the first derivative, and the second derivative is called f double dashed x, or in the y notation, d2y by dx squared. That's how we write it there, noting where those 2's go. So two basic examples to start with. If you'd like to give it a go, pause the video and try it yourself. Differentiating twice. So the first derivative here, you apply the powers term by term, so you get 12x squared plus 10x plus 1, and there's our first derivative. And our second derivative, differentiating again, we get 24x plus 10, and that's all we need to do. Next, the first derivative of this function would be 6x subtract, do you remember the derivative of ln x? It's 1 on x. Now, when we come to do the second derivative, it's perhaps more useful to change that notation into a negative power. So we'll do that now. And then we apply the second derivative. So differentiating term by term, when you bring that power down, you'll get the two negatives, so that will turn into a plus. And we'll just tidy that up for good measure. And there's our second derivative. Moving on. Two applied questions here. The first one, determine the values of x for when the second derivative is 0. Again, in future topics we'll talk about what the significance of the second derivative being 0 is, but for now we're just practicing the skills of finding that. So the first derivative, f dash of x, we're going to have 8x to the power of 3, take 12x squared, take 18x, add 4, and the second derivative, try it yourself, 24x squared, take 24x, take 18. Okay, so now we're ready to set the second derivative equal to 0. So we're going to just write it like that, 24x squared, take 24x, take 18 is equal to 0. We need to start solving for x. So looking for a common factor there first, always the first step. So we've got 6 times what gives us 24? 4. 4 again, and 3. Now, we need to solve for x. So we're going to need to factorize that. So this is a good chance to refresh your memory on how to factorize quadratics. I'm going to quickly run through the two main methods, the splitting the middle term or the cross multiplication method. Okay, splitting the middle term, you need to look at the a and the c. So remember the coefficient, that's a, b, and c. So ac is 4 times by negative 3. That would give you negative 12. So you have to ask yourself, what two numbers when times together gives you negative 12, but when you add them, give that middle term of negative 4. So you start by looking at factors of that 12 or negative 12. You might like to list them. So you have 1 and 12, and then you start thinking about the negatives. No, there's no combination of that that's going to give us negative 4. Maybe 2 and 6 or 3 and 4. Yes, I think within 2 and 6 we'll get 4. So to end up with a negative number when you multiply two numbers, that means one of them has to be a negative. Which combination would end up with a negative 4? You would have positive 2 and negative 6. So there are two factors. So we split the middle term. So obviously when we're solving, we can get rid of that 6 now. We have 4x squared. Here are our two factors, 2x and negative 6x. It doesn't matter which way around you put them, it will all work out in the end. So plus 2x, take 6x, take 3 is equal to 0. Now you factorise in pairs. So you just do it like this, and you're going to end up with one bracket being a common factor. So factorising the pair, what's common? 2x, and what are we left with? 2x plus 1. And in the next pair, you're going to want one bracket to end up looking like that. So thinking about what you're going to have to take out, a negative 3, and you're left with 2x plus 1. Perfect, that's what you want. Then you can see that that bracket is common to both terms, so you can factorise that out to get 2x plus 1. And looking at what is left from each term, the 2x here and then the negative 3, 2x over there equals 0. I'll solve for x on the next one because I've run out of room. So now looking at the cross method. So to do the cross multiplication method, you look at factors of this term. So you split the x squared and the coefficient that goes with it. So pick another colour. So we split the x squared term now, and also split the coefficient. Sometimes it stays with 1 and 4, sometimes it's 2 and 2, and you'll get better at that with practice. To save time, I know where we're heading, so I'm going to do it. And then you look at the c term and you split that into its factors. So let's try, oops, drat, my iPad just dropped out, so bear with me, we'll have to pick it up again. So we had, as a refresher, the second derivative was equal to, well, 4x squared take 3, and we're finding when that's equal to 0. So we have 2x and 2x, and we're splitting this term here, so we're going to get, let's try 3 and 1. Now, two numbers that times to give negative 3. You have to do a bit of playing. Let's try positive 3 and negative 1. And when you cross multiply, what that means is you take that 2x and multiply it by the negative 1, and take this 2x and multiply it by that 3. See what you get. When you do this multiply, you get negative 2x, and that multiply, you get positive 6x. What does that give us? Positive 4x. That's not what we want. We want negative 4x. So that's not going to be the one. So let's try another pair. Rule off. We know it's going to be a 3 and a 1. Let's switch the negatives around. So let's try a negative 3 and a positive 1. So doing that cross multiply gives us negative 6x, and the other one is 2x. That will give us negative 4x, and that's what we want. So then reading off, these are your brackets. That's one bracket, and that's your next bracket. So we have over here 2x take 3, and 2x add 1 equals 0. Solving for x, we're going to get x is equal to 3 on 2 or negative 1 on 2. So there are two x values for when the second derivative is equal to 0. One more example using trigonometry. So first of all, we need to differentiate first and show that it's equal to this. So let's apply the rules. We have our first derivative. So looking at this cos function, you're going to need the chain rule to differentiate that. So you leave the 2 there, you bring the 3, that power down out the front, and you copy and paste the cos with one lower power, and then differentiate the cos, which is minus sine. And then the next term, differentiate that one, minus 3 by minus sine x. Okay, tidy that up. We've got 6 cos x, or cos squared x. My apologies, that should be a negative out the front there. Just testing. And then plus 3 sine x. Now, that does not look like what they want us to write it as. So we're going to have to rearrange this somehow. Look at each term. They've got something in common. Each have a sine x and a number that we could take out as a common factor. When you get the chance, always take out a leading negative. So we're going to take out a negative 3 sine x. And what's left over? 2 cos squared x plus, no, not plus, it would be take 1. Now, as you can see, I've put our double angle formula here, and you may recognise that as the cos 2 theta rule. So in this case, cos of 2x. So we're going to substitute that back in. So you see that you need to be able to recognise all of those identities quite quickly in this course. Perfect, that's what we wanted. So finding the second derivative now, we take this and differentiate it. We're going to need the product rule to do this one. So second derivative, you differentiate the first and leave the second. So differentiate the first will give us 3 cos x, and you leave the second. And now you leave the first, 3 sin x, and differentiate the second. So we're looking at another version of chain rule where you differentiate cos, so you'll get minus sine 2x, and then differentiate the 2x function, which will give you 2. Just tidy that up a little. 3 cos x cos 2x. And what have we got here? The 2 negatives make a plus, and tidy up the numbers to get 6 sine x sine of 2x. And we're done. If you like this video, give it a thumbs up and subscribe to the channel, and the next and final video in this series will be called First Principles. Thank you.